Hello everybody, welcome to my video. Today I'm going to be making my very own DIY game console. Recently I've been obsessed with rhythm games such as Piano Tiles 2 or Osumania, and today we're gonna be incorporating those two games into a little custom circuit I've made inside of this box. Let's get into this. So to start, we're going to need to think how our console is going to be physically, so before we code anything, we need to get our parts and assemble them. In order to do this, we're first going to need a microcontroller. This is basically a mini computer where we can code it to do whatever we want. These are also known as Arduino boards, however, that's not what we're going to use. This is because Arduino boards are not very powerful and have really tight limits, which is 100% not enough for what we're gonna do. However, there is a much more powerful alternative to these Arduino boards that can work in a similar fashion. They are called ESP32 boards. These are 32-bit systems that have much better specifications, and they are also much faster. This is what I'm going to be using as the microcontroller. Besides the microcontroller, the next thing we need is a screen. Here I would have two options. Get a screen that's a full color display, which you could find on older phones or something, that could display basically anything, which would be easy but not interesting as it's gonna turn into like a worse version of a phone, or get an LCD monochrome display. In my last video, at one point I showed this character display. These character displays can, as the name suggests, display characters. The thing is that these characters usually have 16 characters over 2 rows. And evidently we're not trying to print sentences, we want to make a game on it. However, I have one that is a lot bigger, having 20 characters over 4 rows. Each one of these rows can be the lane on which notes can come onto, but that still doesn't fix the problem where these are just letters that don't look good for what we're trying to use them. However, there is a way around it. These character displays have a sheet of all the characters they can print. And besides the ASCII characters, they also have some ASCII extended characters, which include this one. This will just fill all the pixels of the character. This way it can act as a tile, as it's fully filled in with a dark color over a white background. And this, we can totally make it work. Also, this LCD has a I2C backpack. Basically, this makes the LCD have 4 total pins instead of 16. Next, we need some way to control what we're doing and also have a way to press the tiles. To do that, we're going to use 4 buttons, conveniently on this single PCB board. These are perfect for what we need, and we can use 1 button for each lane. And we can also use these buttons to control the menus in the game. And lastly, we need some sound system. It's not a rhythm game if there's no music, and we need some small speakers that can emit sounds. And again, we have 2 options. Either get some phone speakers that can emit basically any sound, but I find it really hard to get my hands on these speakers, and the only thing I can find are these really big speakers that are no good, or we can get some buzzers. These basically emit a static square wave, and this usually would not be good as it would be only one frequency. However, there are some passive buzzers that allow any frequency to be played. This means we can play any note on them, and they work really well for being so small, and for a console we're going to be using 2. For now, these are going to be all the things necessary to make our circuit work, but now it's time to assemble the circuit and see it work. Now if we power the board, we can see the LCD light up. That means everything is connected and ready to go. First, I made this menu where you can select some songs. For now, this doesn't do anything as we have a bigger problem that we need to worry about. How can we get the songs in the console? We can't really load any audio or MIDI instrumental files, so we need to figure out how to put songs into the controller while also using as little memory as possible, as we don't have a lot to work with. To make this easy to use, I made a PC program that works by loading a MIDI file, which is basically a digital music sheet. Then the program transforms this into a unique format. This is a single string of text that contains the entire song plus a bunch of other data. Basically, the format works like this. First you got the name, then what number the song has, then a numeric value that shows us the shortest note in the MIDI. Basically, it looks for the shortest note in the MIDI file. Then based on that, if it's an eighth of a note, then all notes that are eighths of a note are a single tile. And then anything longer is treated as a slider note. And if it's shorter, then they are grouped as 2 notes at a time. If this value is 1, then the shortest note is a quarter. If 0.5, then it's an eighth, and so on. Then we got a BPM value. This is only available for the first star, as songs in Piano Tiles have the BPM changes after each star. Then we have the actual data. Basically, each character represents a note value, and there are some special characters like the dash that show a slider note and the asterisks that show a combo note. This is repeated a total of 3 times for each star, each with their own BPM value, split by an exclamation mark. And these are going to be turned into notes and played on the first speaker. When it gets to a hashtag, it goes into the data that the second speaker is going to play. The format is the same though, just there are no BPM values or star splitting as we don't need it. Then at the very end, there's a song condition, basically what is needed to unlock the song. It can be nothing, a required level, or a price tag. With this system, we get some strings that we can directly place into our code as a full song with all the data, while also occupying less than half a kilobyte of data. With the song format figured out, now we can make a system that reads the data and places the name, its index, and the condition. But now these songs don't do anything, so now we need to make the actual gameplay, which is the actual rhythm game. To make this easier, I also added a direct system to test it on the PC app, which is going to use the exact same code as the board. But now we need to actually make the system do something. As I've said earlier on, the LCD I'm using is a character display, and we can't directly modify the pixels on the screen. So we need to make a system that scrolls down these filled tiles across the character spaces to make it look like it's moving down. First, we take all the data from our song string, and then we save the BPM values. And more importantly, we save all the note values in 4 character arrays. And each note is placed in a random array with the condition to not be the same as the last note, so we don't have 2 notes on the same lane back to back. And we use a similar system for sliders and the combo notes. And the sliders in our case works by stacking notes on top of each other. With the data ready, we also need some numeric values. One stores our progress, which shows us how much the screen has scrolled down, and then another one that shows us the next note that has to be tapped. Then we make the tiles visually move down the screen. What we do is we take each row one at a time, and the screen will be vertical when playing. What we do is based on what progress value there is, we put in the notes on that specific lane with the following rule. 1 unit of progress means 1 tile. 1 tile is 3 characters on the LCD. And now we only put in notes that have an index greater or equal to the next note value, as all other notes have been pressed. This way, we have 2 stages in between moving a full tile. And with this system, the user must press the first note coming down and not any of the other notes that are not before the first one. Besides all this, whenever the BPM is changed, we get a star. And it works just like in piano tiles too. Firstly, you have stars, and when it starts to loop back around, you start to get crowns. With the system complete and working, I added it to my console and the PC app. But you may notice on the PC app, there's also a note counter with a custom number font. You see, these LCDs have predefined numbers, just the problem is that they only work if the console is oriented horizontally, and by placing them like this vertically, it would not work. So how can we achieve this? Well, there's one more cool thing about these character LCDs. Besides the characters you already have available, there are 8 slots where you can define your own custom characters. This means that we can make our own digits and define them into the LCD. The problem with this is that we need 10 digits and the LCD only has 8 slots. So how can we get around this? The thing is that this doesn't mean we define 8 characters and they are stuck. We can redefine them at any point. Just 8 can exist at the same time. And since we have a maximum of 4 different digits at a time, we can 100% fit in these limits. So I wrote some code that defines these custom characters every time the score value is changed. And now we have a proper score counter even in the vertical position. And also, this score works like this. If a note is pressed, you get 1 point. If a combo note is pressed, you get 3. And for a slider, for each tile of length, you get 1 point. Now, besides these 4 characters, we still have 4 slots empty. And I got an idea. Since we can define custom characters, we can make the scrolling system look even better. Basically, if we define these 2 characters that are on the top and the bottom half of a full character, then we can make a smoothing system. If the progress value is in between 2 of the phases, then we can make another one where instead of the notes moving down 1 character, instead the top one is replaced with the top half, and then the bottom half is placed under the other tiles. This way we make 5 in between phases instead of 2, and now it moves much more smoothly. And with the 2 remaining character slots, I made this partially filled checkerboard pattern that will show when the note is pressed. It's printed as a checkerboard panel to look like it's fading out. And I also added at the bottom of the screen these characters that light up when you have a button pressed, like kind of in some other rhythm games I've played, where this checkerboard tile is also found. And for the last character, I defined it as a vertical decimal point. And for now this has no use, but later on it will be very important. Now, with the entire system done, I added some menus to make navigating the game a lot easier. Besides the song select and the main player menu, I also added a screen when the song ends which shows you your score and stars obtained. Now, I haven't really talked about saving data. On an ESP32 board, there are 20 kilobytes of non-volatile memory where you can save variables. And I use this to save your current level, your coin count, and specific data on songs. That includes the amount of stars and your personal best, which I added that so when you play a song, before it starts, it shows you your personal best. I also made the system to lock you out of a song if you don't have the required level or have not bought the song yet. So with this all done, I decided to make the other mode present in Piano Tiles 2, and that's the Hall Challenge. Basically, this is a song that goes on forever, but instead of getting score, you have this notes per second value that is constantly increasing. To make this, I make a separate menu for the Hall challenges, and instead of stars and score, you got notes per second. This is the main reason we define one of the custom characters as a decimal point, so now we can display it with 2 decimal points of precision. This mode works about the same way as the regular mode, as you still keep going until you miss a note, but this time the BPM keeps getting faster and faster. Now, something I have not added yet is a stamina system. In Piano Tiles 2, you have these hearts that act as stamina, and if you want to play a song, you need at least 1, and for Hall songs you need 2. The main reason I put away this idea is the way this works in Piano Tiles 2 is it checks when you exit the app and re-enter it, and from there calculate how much stamina you regenerated. The problem is this board does not keep track of time if it's off, and even when it's on, its internal timer is not very precise. In order to fix both of these problems, we need a real-time clock module. This is a module that has an ultra-precise clock, and it also has a slot for a battery, which still keeps track of the time when it's not powered. And now we can make a system that keeps track of time and regenerates our stamina even when the console is not turned on. So, with the clock installed, I decided to add some more commands onto the main menu. You have the main 4 buttons, but if you press 2 at a time, you can access other menus. If you press the first 2, it takes you onto this level menu, where it shows you your progress to the next level. To make this really big digit, I made a system that fills the custom character slots in the LCD with 8 segment designs, and with these we can arrange them to make numbers. I also took this opportunity to make a level up screen. Basically, when you finish a song, if you level up, you're now met with this level up screen that uses the same big digit system, but the digits are now even bigger than before. Another menu I added is when you press the bottom 2 buttons, it takes you into the stamina menu, where you can buy more stamina with your coins. And the last menu I added is when you press the middle 2 buttons, it takes you into the settings menu. I added a bunch of settings in the setting menu, split across pages. First up, the gameplay. You have frames per second, the smoothing system that I explained earlier on, and a mode setting, where you can either select score or accuracy. I'll explain that in a moment, but next we have the save data. Here I added an account system, where you can switch between 3 accounts to save your progress. And I also added a total playtime counter for each. There's also this menu where you can check how much space you have left for save data, as it's so limited, and a menu where you can clear your save data. Next, we have clock settings. Here you can set the time, enable daylight savings mode, and the format in which the clock is in. I know this seems irrelevant for the reason we're using it, but it will soon become very important. Next, we have statistics. These aren't settings, it just counts your score, stars, and crowns across all accounts without being reset. I just think it's cool to have this. And the last page we have are the advanced settings. Here you can set the clock speed for our ESP32 board, as using slower speeds will use much less current. However, the performance is affected quite a lot, so you can enable this sidebar. Basically, this sidebar is used to show you what each button does. And when I assemble this console, the buttons will sit directly under the screen. And with this, you can toggle it on or off. And this ignore song number setting, basically, songs have whatever number you set them to have on the PC app. And if you enable this setting, it forces the numbers to be consecutive, started from 1. Now these are all the settings so far, but back to what I said about that game mode setting. When toggling this setting, you basically change how the game is played. If you set it on score, it works just like Piano Tiles 2, which is basically the system we already have. But on accuracy mode, it will work kind of like Osumania. You are now judged by your accuracy instead of score, and when you miss a note, you don't fail. At the end, instead of getting stars or crowns, you instead get a ranking. The best of them being an SS for 100%, then S, A, B, and so on. But we need to actually make this system as it doesn't do anything yet. The first thing I did is when this mode is turned on, the menu will now show rankings instead of the stars. When you select a song, before playing it, it shows you your personal best. But this time, your best accuracy. When actually playing, the entire system is a bit different. Yes, you still have to press the notes coming down, but you don't do that whenever. You have to hit them when they are as close as possible to this line. If you hit it close enough, you get full points. But the further away you hit it, the less points you get, and these points make up your accuracy. At the top, you can see your accuracy instead of the score, and the song doesn't loop over like it does in the regular mode. Instead, when the song ends, when it reaches its end, or where the third star would be in the regular mode. When you finish a song, the menu is also changed. Instead of seeing how many stars you get, you see your rank in big letters. Now, this is for the regular song. For haul challenges, it mainly works the same way. You can only play the song once, and instead of the notes per second, you have your accuracy, but the speed still increases and it just stops when the song ends. And instead of saving your fastest time, it instead saves the rank and accuracy you got. Now, this is about everything in this, but there was another thing I needed to modify. This board will be powered on from battery. In this case, this external battery, which will get it to run for about 20 hours when turned on. But at the moment, the console is constantly turned on, and we need to add a way to close it like a phone, for example. Firstly, we need to add an actual button that we'll use as the power button. Firstly, when pressing this button, the console enters a state of sleep. These boards cannot be fully powered off, and if they are fully powered off, there would be no easy way to get it back on, so we put the board in a state of sleep where its button wakes it up from that sleep. But there's also another thing. When it's sleeping, it's still powering on everything else connected to the circuit. So we can't really turn off a lot of the stuff here, but we can make the buzzers not emit any sound and turn off the backlight of the LCD. This way there's barely any current still being used by the components, and this will last a couple of days with the battery, which is about how much a phone would last when turned off. The only thing I don't really like at the moment is the fact that everything is turned off, but it doesn't really look very good. And you know how some phones have an always on display? Well, I want to implement that onto my system as well. This is the reason why I added those clock settings in the settings menu. So now when the console is turned off, the backlight does turn off, but now you have the current time and date shown on the screen. So now you can actually see if the console has any battery left, and it just looks really cool to begin with. One more thing I added is when the console is on, if the power button is pressed, it turns off the console. But if you hold it down, you get to access two quick settings that can toggle the sound or the backlight of the LCD when you let go of the button. So at this point, we got basically every feature made in the game. And now with the next step is to make songs for it. To make these songs, I'll use a MIDI editing software. In my case, I found a program called Domino, and I collected a list of songs that I'm going to add in a game. I know there aren't a lot, but I needed some songs that were free to use, so I made all these songs, converted them with the PC app I made for this, and besides those, I also made some haul challenges. 3 main levels, which all made by combining some of the songs included in the song list. So now we are completely done with working on the actual game. But at the moment, our circuit is just kind of sitting on my desk, so we needed to put it all together in a box and arrange the stuff inside to make it look like some kind of game console. In order to do this, we need to add all the stuff that needs a specific position first, and then everything else, whether it has space to sit. Firstly, I need to find some kind of container to put this all in, and the best thing I could come up with is this tofu box.
Okay, me from the future here. The tofu box ended up being far too small for me to be able to fit everything inside of it, so I had to find a bigger alternative. Now, before actually doing this, I decided to add 2 more things onto the console. When it's turned off, I changed the clock to instead use our big digit system, for a better looking clock instead of the text being on one line. And the last thing I added is a cheat menu. When testing, you may have noticed this when the console turns on, and that's from the cheat menu. When pushing all 4 buttons at once, you can activate this menu where you have cheats for infinite XP and cash, autoplayer, and a speed changer that can be activated anytime. But this menu can only be activated if you set it in the code from this variable. Now back to assembly, the best thing I could find is this box that a breadboard that I bought came in. And just, it wasn't really tall enough, so I bought the same breadboard and I burned a hole through the 2 boxes so I can stick them together. With our bigger box, I poked holes on the top for the LCD and our 4 buttons. Then I made some holes on the box itself for the power button, the 2 buzzers, and a charging port. Since we have a rechargeable external battery, we can just take a USB-C extension cable, run it through the bottom, and we have the input sitting on the hole I made it for this. After this, I added the buzzers and the power button in place, and then I needed to fit everything else inside it. Now the assembly was a pain to say the least, but when all said and done, bada bing bada boom, we have our fully finished console fully assembled.
So yeah, now my circuit actually looks somewhat like a console, and I'm done working on it. But now, this part of the video, I'm going to show you how to make this console yourself. In the link in the description, you will find the itch.io link for this project, where you can find everything you need to make this work yourself. First, you're going to need to assemble the actual console first. And here are all the parts I used. And to assemble them, first I need to clarify one thing on how the pins on the breadboard work. The rows with many pins, I labeled them from the letter A to E. And each column is labeled with a number starting from 1. Now follow my instructions. Take your board and connect the ground pin to A1 on the breadboard, then the 3.3 volt pin to A2, then the 5 volt pin to A3. Take your I2C level shifter, connect B1 to the 3.3 volt, then B2 to the ground next to it, then connect SDA and SCL from that side onto the board on pins 21 and 22 respectively. Then on the other side of the shifter, connect B3 to 5 volt and A4 to the ground. Then take SDA and SCL, connect it to A5 and A6 respectively. Take C3, connect it to the VCC of your LCD. Then take C4, C5 and C6 and connect them to the ground, SDA and SCL respectively. Now your LCD has power. Take C1, connect it to the ground of your first buzzer, then take C2 and connect it to the VCC, and then connect the I/O pin to pin 18 on the board. Then take D1 and D2, connect it to the ground and VCC respectively on the second buzzer, then connect I/O to pin 19 on the board. Then take a jumper wire and connect it from E1 to E7 on the breadboard. Then take D7 and connect it to the ground of your 4-button module, and for K1, K2, K3 and K4, connect them to the pins 32, 33, 25 and 26 on the board respectively. Then take C7, connect it to the ground of your button, and then take another leg and connect it to pin 4 on the board. Lastly, take D3, D4, D5 and D6 and connect them to the VCC, ground, SDA and SCL pins on the real-time clock module respectively. So now if everything is working correctly, then everything should work. Now in the itch.io page, if you download the master zip file, you'll find 3 files, 2 of them being executables. Run LT2 setup. Here you can set up all the connections you made for the board, and you can put all the songs you want that are going to appear in the app. You start off with the regular songs I shown in the video, but to add more you can use the other program called LT2 Convert, where you can place MIDI files and set up their respective data, and it will generate a string of text. Then you copy that, click the Add Song or Add Hall Challenge button, paste the text in, and now you have it in the list of songs. Once you have all the data set up, click the Generate button. This will generate the code based on the data you put in the program. Then you just take this code and place it in Arduino IDE. From there you click this book icon on the left, which lets you install libraries. Here you need to install all of these libraries. Then connect your board via USB to your computer and click the upload button. If all goes according to plan, then you should have a fully functional console that can play my really bad homemade version of Piano Tiles 2.
Thank you for watching. I hope you enjoyed it, and I'll see you in the next one. Bye bye.